So we are still in 2.2. We're talking about symmetry. A function can be symmetric. And if it is symmetric with respect to WRT, I'm lazy, WRT, the y-axis, we call this function even. If it is. If it is symmetric with respect to the y-axis, we call this function even. That has nothing to do with, it's not connected to odd or even numbers. It's just a name. We call that function even if it is symmetric with respect to the y-axis. The other possibility is with respect to the origin. If that happens, we call that function odd. Nothing to do with odd numbers. It's not connected to odd numbers. It's just a name. Functions don't have to be symmetric. If a function is symmetric with respect to the y-axis, it's even. If it's symmetric with respect to the origin, it's odd. But now let's talk about the algebra behind it, behind even and behind odd. So I'm going to give two examples, two graphs. You may remember them or not. We will review them in section 2.5, but that's for the next test. Here is one example. I will tell you what function this is. You may remember. This is y equals x squared. And here's another function. I'll give you the formula for that one too. Is y equals x cubed. They are both what type of functions? X squared and x cubed. What type of functions are they? We have some idea about linear, quadratic, polynomial. We have some idea about rational functions, radical functions. What do you think x squared and x cubed are? It's a big, big umbrella of functions. This is quadratic indeed, but what type of function is quadratic? Under which umbrella? Polynomial, very good. Polynomial. Remember we did what? When we factored the first week of classes, we said binomial, trinomial, polynomial, right? They're all polynomials. Yes, x squared and x cubed and x to the fourth and x, they're all polynomial, different degrees, but they're all polynomial. Okay, so I am going to cut this graph horizontally, and I am going to create 2 points. I'm going to call this point having x coordinate, and will you please tell me what is the y coordinate of this point? Assume you don't know what the function is. So this is just a function f of x. What would be the y coordinate when x is x? What would be the y coordinate if I make this 2? What will that be? F of 2. F of 2. Whatever f is. F of 2. So then if this is x, what is y? F of x. F of x. Very good. Symmetric on the other side, I have negative x. Can anyone give us the y coordinate of this point now? Awesome. Excellent. Indeed, f of negative x. Can you please give me the relationship according to the graph? I graphed a function that was symmetric with respect to the y-axis. So I created 2 points. One has coordinates x, f of x. The other one has negative x, f of negative x. And now I'm asking you about the relationship between f of negative x and f of x. What would you say? Say it again. The relationship. Indeed, absolutely. So a function is even if f of negative x does not change f of x in any way, shape, or form. So here is a simple example. Let's say f of x equals 3x to the fourth minus x squared. In order to show that this function is or is not symmetric, I have to find this quantity. Can anyone dictate? When I want to find f of negative x, can anyone dictate what to write? We know what the function is telling us. We know how to evaluate the function for anything, including negative x. So can you please tell me what to write? I have to copy 3 first. You cannot tell me that, right? Then what do I have to write? You have to say what? What is the next step? What do I have to write? Say it again. Excellent. Negative x to the 4th power. Thank you. Minus. In. Yes. Negative x squared. That's what we do first. We replace x by negative x everywhere. So now negative x to the 2nd power, what will that simplify to? Say it louder. Why do I write? Indeed. Awesome. What does this simplify to? Say it again. X to the 4th power. So what is the final simplified form then? 3. Very good. X to the 4th. Very good. Now the question is, does this equal f the original function? Does it? Was this the original function? After replacing x by negative x, did we get the original function back? What do we conclude about this function? Is this function symmetric or not?
Symmetric.
Symmetric with respect to the y-axis, which means it's an even function. Is this clear?
Yes, ma'am.
Awesome. Let's look at the other possibility. This time, yes, any questions? Go ahead. Any questions, please? You're helping me and you're helping your colleagues. If you have questions, please. Anyone? Okay, this time I'm going to do something else. I'm going to draw a dotted line between 2 points, one in the 1st quadrant, one in the 3rd quadrant, and the line passes through the origin. So I'm going to say that this point has coordinate x, and can you give me the y coordinate? So this is still a function f of x. I told you what it is, but we don't need it. So what is the y coordinate?
Sorry, can you see the x?
Yes, I'm given x, and I would like to determine the y coordinate. What is it? Exactly what we did before, a minute ago. Of course, this is f of x. Of course, on this side, I have another point. Can anyone give us the x coordinate of this point?
Negative x.
No, the x coordinate cannot be f of negative x, but the x coordinate is? Very good. And now I also want to determine the y coordinate.
F of negative x.
Very good. Now I would like you to establish the relationship between f of negative x and f of x. Oops, I didn't mean to put the equal symbol.
Parallel.
So I would like you to establish the relationship between, because I'm hoping that in this way you will remember it.
It's parallel.
How can I say that the relationship between 2 numbers is parallel? I won't be able to. It doesn't mean anything. So what is the relationship between this number, which is f of x, and this number, which is f of negative x? If this is 15, what do you expect this to be? Right. If this is 10, what do you expect this to be? Correct. So then, what is the relationship between 10 and negative 10? Or the relationship between 15 and negative 15?
Negative x.
Exactly. But not negative x, but negative?
Y.
Yes. So this is the relationship between f of negative x and f of x when the function is odd. For an odd function, the two are not the same. They're opposites of each other. Okay, so now let's look at an example. Here is a function. Let's say 3x cubed minus 2x. We're asked to show whether this function is odd. The question is it odd? What do I have to determine? Based on what we just looked at, a previous problem, what will you tell me that I have to find? I have to calculate what? What did we calculate in the previous example? It's the same thing we have to calculate now. What did we calculate in the previous example? Yes, we calculate of negative x. It's the same thing. Nothing changes. I'm sorry? I thought you said negative f of x or something. I'm wrong. If I misheard, I apologize. So f of negative x is the same quantity in both cases, and we have to determine. Can anyone dictate what to write, please? I think that moving forward, if I see a cell phone, I will write down your name and subtract 1 point from your next test. Great. If I see your cell phone, I'm not going to say anything. I'm just going to write -1. So I'm hoping that you're going to put them away. They should not be on your table. Your cell phones should not be on your table. If I see them again, I will start deducting points. If you play with them under the table, I will have to do the same thing. That's the policy. No cell phones unless you have an emergency. If you have an emergency, it's a different story. You go outside and you talk, or whatever you need to do. Okay, so moving forward, if I see a cell phone, I will have to deduct points from your next test grade. Thank you. Okay, can anyone tell us what to write?
3.
Yes? I need to hear parentheses because we are plugging in a negative number. If I don't hear parentheses, I cannot write. It will not be correct. Yes, negative x to the third. Very good. -2. Parentheses. Awesome. Good. So now, be very careful with this, and be very careful with this. I mean, I should say this, to be exact. So negative x to the third power, what will that equal to? I agree. It's negative x cubed. But now I have to multiply by 3. What should I get? Negative 3x cubed. Awesome. Now please calculate this. The -2 multiplied by negative x plus 2x. Now here I have several options. Any questions? Go ahead. Any questions, please? Okay. So yes, go ahead, please.
Does that mean that that's wrong? Because you see how it's 3 negative x to the third, but like on the last example, 3 negative x to the fourth was just 3.
4 negatives make a positive. 3 negatives make a negative. So please remember that. Any even number in a product, any even number of negatives, the result is positive. Any odd number of negatives, the result is negative. Does that make sense?
Yes.
Other questions, please ask anything. Awesome. So now the questions I have here, because now I know both odd and even, I'm asking myself, does this equal f of x? If you say yes, then the function is even. Now the question is, does it equal negative f of x? If you say yes, the function will be odd, and it can be none of the above, to be exact. It doesn't have to be symmetric. It's nice if it is. You will see in chapter 3 how important this is when we start graphing those functions, polynomials. Okay, so now, is this the same with the original function? And the answer is absolutely not. So the function is not even. Now, before I continue, I have to say that a function cannot be odd and even at the same time. To be exact, to be honest and fair to you, the only function that is odd and even is y equals 0, the x-axis. But who cares about that function? That's the only function that is symmetric with respect to the y-axis and with respect to the origin. But nobody cares about it. So if the function is not even, it can be odd. If the function is not odd, it could be even, but not both. Okay, so now I have to identify what this means. How do I get this quantity? By simply multiplying both sides here by -1. Negative f of x negative this, and positive this. So this quantity is here now. If they are the same, then I will say odd. If they're not the same, and I'll cross this out. If they're not the same, then I will say the function is not even, the function is not odd, neither nor, so it's not symmetric. So what do we conclude? It is odd, because when we calculated the opposite of f of x, we obtained the same function with f of negative x. So f of negative x equals the opposite of f of x, therefore the function is odd. So that's about symmetry, and we'll have examples in a minute. Any questions from me right now? Any questions? So remember the two conditions. F of negative x equals f of x. I'm going to write them here one more time. And f of negative x equals the opposite of f of x. So this is for symmetry. This is even, and this is odd. A function cannot be symmetric with respect to the x-axis, only with respect to the y-axis or with respect to the origin. A function that is symmetric with respect to the x-axis is not a function by the vertical line test. And now let's talk about max-min. Let's look at two different situations. One situation in which a function, and then we'll work on problems in a minute from your book. So here's the first situation in which a function, can anyone identify the domain of this function? Can anyone identify the domain of this function? Exactly. Exactly. All real numbers. Perfect. And now let me give you another example. Here's another function. Is it a function, by the way? By the? Exactly. Awesome. Can anyone give us a domain of this one? And then we'll talk about both. So between -1 and 10. Do you all agree with the domain of the second function between -1 and 10? I see the cell phone. I see it. Okay. Got it. So I see that this function has here a peak. It goes up and it continues down till this point, and then it goes up. Would you accept that? I'm going to give a point here, let's say 10. So we've discussed this, increasing, decreasing before. So the function is increasing for x between -infinity and 0, and also from 10 to infinity. And the function is decreasing from x equals 0 till x equals 10. This point is called local max. If you don't like the word local, call it relative. They are the same. It's a local or relative max. This one is a local, of course, a relative min. So let me identify the characteristic of a local. If the function exists on both sides, and I can show you the open interval where the function values are smaller than this one, this is the highest, then that is a local. The same thing here. It's a local because the function exists on both sides, and I can show you an open interval where the function values are bigger than this one. This is the smallest. That's local. Now, is this local? Yes, it is, because I can show you the interval left and right. So this is, bless you, local or relative min. It's also an absolute min for this function. Why? Because there is no other lower value than that. But now I'm asking you this, is this a local max?
No.
No, because I cannot show you the open interval left and right. The function is not defined on the left. Still, this point is the largest, the highest, has the highest y value. It would be an absolute max. But not local. Not local max. And this one happens to be nothing. First of all, it's not local. Secondly, it's not the highest and it's not the lowest. So this endpoint here is nothing. Now we have enough information to start working on some problems. I do not remember, I don't think we did any of these problems. I like to look at 50. So 50 on page 251. Any questions? You needed something from here?
Yeah.
Okay. Let's go back. Say it again.
I just needed to write the points.
Yes, of course. So this is an absolute, it's not local because the function is not defined on the left-hand side. I cannot show the open interval. This is nothing. It's not the highest, it's not the lowest, and it cannot be, the endpoints can never be local or relative. This one happens to be the local, but also because I can show the open interval, or function values are bigger than this one. And it's also absolute because there is, for this particular function defined here, this is the smallest possible y value.
Okay.
Better? Any questions for me? Okay, so let's take a look at this graph. So this is problem 50 on page, I'm going to write these with you. So let's answer everything we need from here. So this is 50 on page 251. First question, they're asking us to find the domain of this function. Let's identify the domain of this function. Very good. From the arrows point everywhere, in other words. So it's from negative infinity to positive infinity on the x-axis. The domain is negative infinity to infinity. Can anyone give us the range? Part B. Indeed, from the smallest y value till the possible largest value that I see 4. So it's negative infinity to 4 with a bracket. Next question, the x-intercepts, please. I prefer ordered pair format, but it's okay. So the x-intercepts negative 4 comma 0 and 4 comma 0. Do we all see the x-intercepts as negative 4 0 and 4 0? Okay. The y-intercept, please. 0 comma 1. Do we all see the y-intercept as being 0 comma 1? Perfect. Intervals on which f is increasing. Part E. F increasing on. Remember, we are not looking at the y values. We are looking at the trend where it happens, not from what to what. So as you see, this function is increasing, then decreasing, then increasing, and decreasing. So it's increasing on the interval. I can't hear you. From negative infinity to negative 2, the function is increasing. Union. From 0 till, very good, 0, 3. F, intervals on which the function is decreasing. Anyone, please. We're not talking about the y values. We're talking about the x values for which the function.
Negative 2 to 0.
Very good. From negative 2 to 0, the function is decreasing.
3 to infinity.
Awesome. 3 to infinity. We're not talking about the y values. We say between 3 and infinity. Good. Values of x for which f of x is less than or equal to 0. So let's look at this graph, and this is a very important type of question. Let's analyze this graph for a moment. I see in the graph between negative infinity and negative 4 is below the x-axis. Would you agree? So if you pick negative 5 and you want to find the y value, is it going to be a positive number or a negative number?
Negative.
Correct. When the graph is below the x-axis, all the y values will be negative. Same thing here. If I ask you to evaluate somewhere between 4 and infinity, like for 10, what type of number will you get?
Negative.
Correct. Okay. Now between negative 4 and positive 4, do you see the graph is entirely above the x-axis? Any value you pick, 1, 2, negative 0.5, all those values will give you what type of y value? Positive, correct. So now we are asked in this question, we're asked to find the x values for which the function values are 0 or less. Less than or equal to f less than or equal to 0. The function, which means the y values. So find x such that the y values are 0 or less. What will you say? Yes. So between negative infinity and negative 4, including negative 4, union. Two. Exactly. So the answer will be for x in the interval negative infinity, negative 4, union 4 to infinity. I'll show you these in a minute. Next question. Find the numbers at which f has a relative max. Does this function have a relative max anywhere? Where? At
-2, 4.
at negative 2 and at 4 is 0. We already wrote that a minute ago, right? It cannot be anything else but 0. Correct. Very good. So at x equals, you said negative 2, indeed, and x equals 3, a relative max. Perfect. Next question. Find the relative max of f. Now, we're not asked where the relative max is. We're asked how much is it. So please give me the how much. That is I. What is the relative max when x is negative 2? So at x equals negative 2, the relative max is 4. Do you all agree with 4? At negative 2, the relative max is 4. Do you agree with that? Perfect. And at x equals 3, the relative max is 2. So please differentiate between the two questions. The first one is asking us where is the maximum. The other one, it says how much. Okay? Where? Negative 2 and 3. How much? 4 and 2 respectively. Is that clear? Where? It's asking for x. How much? It's asking for y. Awesome. Okay. J. F of negative 2. Can we determine f of negative 2? What will you say? Exactly. We just determined. They're asking us for it again. They think they're tricky. Okay. The values of x for which f of x is 0. That's k. F of x is 0. When f of x is 0, what are we looking for? We're either looking for the zeros of the function, or we are looking for the, how are they called? When the function is 0. We're either looking for the zeros of the function or X-intercepts. Correct. Very good. We already determined them. They're asking the same question in a different way. So when f of x is 0, what do we write? X equals negative 4 and x equals? Awesome. Okay. Final question here. L. Is this function even, odd, or none of the above? Correct. It's not symmetric with respect to the y-axis. Symmetric with respect to the y-axis, this should have been exactly the same here and here. It's not symmetric with respect to the y-axis. Is it symmetric with respect to the origin? No. Because what I see here, I don't see here. What I see here, I don't see here. So it's not odd. It's not symmetric with respect to the origin. And therefore, it's not symmetric. Not symmetric. Now, please let me know if we understand this type of problem, because something like this will be on your test. Do you think we need another one? Okay, very good. So let's conclude this one first, and then we'll pick another. So these were my notes. You were giving me the answers, and I wrote them down for you. Okay, the first one was the domain. The second one was range. The next one were the X-intercepts. The next one was the Y-intercept. The next one was when the function is increasing. Of course, when the function is decreasing, notice that there are no brackets. We don't write any brackets, for it's just a trend. When the function, we're asked to determine the x values when the function is less than or equal to 0. Sorry, I forgot the parenthesis here. Then we're asked where does it have a relative max, -2 and 3. And at x equals -2, the relative max is 4. At x equals 3, the relative max is 2. We're asked again to find f of -2, and we got 4. Then we were asked again to find the zeros of the function, or the x-intercepts. And finally, we were asked to find if the function is symmetric, either with respect to the origin or with respect to the y-axis. And we concluded that the function was not symmetric. Let me know if you're done writing this so we can look at another example. Yes, Tim?
On letter E and F,
Yes,
what can you?
f is
read?
increasing,
Okay.
up, going up. F is increasing on the interval, -∞ to -2 union 0, 3.
Union 0.
And then f down.
One more time on what union means.
Oh, okay. If two sets do not have anything in common, right? If they overlap, then if I have a situation, very good question actually. So if I have something like this is one set, let's say between 0 and 10. And the other one, let's say, is between 5 and 15, right? So all I have basically is 0 to 15.
Okay. And the union would be between.
But
5 and 10.
no, that's the intersection. But if I have a situation like this, right, this is sufficient. If I write 5 twice, it doesn't mean that I have two numbers 5. If I write 10 twice, it doesn't mean that I have 10 twice, right? I still have between 0 and 15. But if I have this scenario, if I have 0 to 10 and 20 to 30, how do I give you the solution? I will say it's between 0 and 10 or 20, 30.
Okay.
It's the or. Right?
Another word for
So
or.
exactly. So you can find the solutions either between 0 and 10, or more solutions will be found between 20 and 30.
Did you go over that at all? Or did I miss what you mean?
No, you did not miss.
It was the assumption.
I assume that, but you. I'm waiting for
Yeah,
you guys to
that's
say
why I asked.
it's not clear to me. Show me, right?
That's why I asked. I
Right,
just wanted to be sure.
Right. We used this when we solved absolute value inequalities, because they were to the left of 2 union to the right of -2. I'm sorry, to your left. Your left of -2 union to the right of 2. In order to put them together, I either use the word OR or I put the union symbol. Better?
Yes.
Okay.
Thank you.
Now here, thank you. So here the intersection will be, if I intersect these two, the answer will be 5 comma 10. And when will I want to do the intersection? I will always want to do intersection when I'm finding common domain. And we get this to this at the end of chapter 2. When I want to create a function adding two functions. If one is defined here and the other one is defined here, I can't create a function because they don't have a common domain. Which number do I plug in? This one I cannot plug in the second one. This one I cannot plug in the first one. So I can't add them. It will make no sense because there is not even one x value for which the function exists. So then I will need the intersection, the common domain. That's when I use this, when they have common territory. But in this case, when I present the solution, I have to use the or the union. Better?
Yes.
I know it was a long explanation. Sorry about that. My apologies. Okay, are we done with this? Okay, are we ready for another example then? Okay. Okay, so let's look at this one quickly. I'm not going to write the answers for this because I want to finish up 2, 3, and 2, 4. This is 2, 3, and 2, 4 are review. Okay, I'm just going to ask you, and if you want to write them down, please do so. The domain of this function. Exactly. The arrow, the full point, from negative infinity to 6. That's the entire domain. Perfect. Range, please. Perfect. From negative infinity to 1. Very good. Awesome. Next question. The zeros of f of x. Please ask. This is an arrow. It goes to negative infinity from negative infinity to 1. Is that clear? Yes? Ariel, is that okay? Because I saw you say y. You did? Awesome. The zeros of f of x. Negative 3 comma 0 and
3
comma
0.
perfect. Awesome. F of 0, please.
F of 0. Oh, 1.
1. Very good. Intervals on which f is increasing.
Negative 2 1.
The function is increasing from negative infinity till negative 2. The function is increasing for x between negative infinity and negative 2. Is that okay? Intervals of which a function is decreasing.
2 6.
Very good. Indeed, from x equals 2 till x equals 6, the function is decreasing. Awesome. Intervals on which f is constant.
1.
Between negative 2 and 2, the function is constant. Not how much. We're not looking at the y values. Please understand that. Values of x for which f of x is positive. Not 0, just positive.
Okay.
Say it again.
Okay.
Where is above the x-axis? For which x values is above the x-axis?
Negative 3.
From negative 3 to 3. Very good. From negative 3 to 3, the function is above the x-axis, or function values will be positive. Values of x for which f of x equals negative 2. F of x equals negative 2. F of x, I'm looking for my pencil. Please wait. Is that okay? Everything okay? F of x equals negative 2, as we discussed numerous times. We cross the y, we draw a horizontal line. It crosses the function in these 2 points, and this is what we need to read. So the values of x for which f of x is negative 2, and the answer is negative 5 and awesome. Is this function odd, even, or none of the above? Very good. It's not symmetric. Very good. Awesome. The function is indeed not symmetric. F of 2. Is f of 2 a relative max? Yes. The book says no. I said yes, because I can show you in the calculus book that I would not ask you something like this because I think it's wrong. The book is wrong. They say that this point cannot equal the function value on this side, but it can. It can. So your book says that it's a corner because this values on the left-hand side are the same with this height. This is not a relative max. I consider it a relative max because it can be equal to. But let's go with your book. But I can show you that it's incorrect. But that's fine. Any questions? Any questions? Okay, let's take a look at the last two sections of this material for the test. 2.3 and 2.4 together. This is all about lines. We're going to go back. Oops, yeah, let me zoom in. Thank you. So this is all about lines. It's about graphing using X and Y intercepts, not using the slope. Then we are going to review the equation of the slope or the definition of the slope, which is, if you remember, it's rise over run. Or y2 minus y1 over x2 minus x1. These are all known from other courses. Nothing is new here. Then there is a y equals mx plus b. What does b mean? Awesome, indeed. It's 0 comma b, which is the y-intercept. Very good. This is the slope-intercept form. Then we're going to look at y minus y1 equals the slope times x minus x1, which is point slope form. And just two other items here, and that's it, and we can look at problems. This is a quick review for you. Parallel lines and perpendicular. Anyone remembers what is the relationship between the slopes of two lines that are parallel? This is one line, this is the other, they are parallel. What is the slope, the relationship between the slope m1 and the slope m2? They have to be the same, very good. Otherwise, they will not be parallel if they don't have the same steepness. Okay, what about perpendicular lines? So here, these are two perpendicular lines. They form 4 90-degree angles, perpendicular. This is m1. This line has slope m1, and the other one has slope m2. What is the relationship between m1 and m2 when lines are perpendicular? Very good. So the opposite negative reciprocal of each other. This is the relationship with two lines that are perpendicular. I prefer cross-multiplying and saying that the product of the slope is -1. These are the same. You either say that this one slope is the negative multiplicative inverse of the other, which will take you 5 seconds to say, or you say in 1 second or a second and a half, the product is -1. Same thing. Okay, we're ready to practice now.